Welcome to Broad Eye, the podcast that explores knowledge gaps in ophthalmology and eye care. Hello and welcome to another episode of the Broad Eye podcast. My name is Sean Maloney and I'm here today with my good friend and co-host, Dr. Bruno Fernandez. Bruno, welcome.
How's it going, Sean? Glad to be here again with you.
There you go. This is becoming an everyday thing. Every episode you're there. So today we have a very special guest. His name is Brad Folkens. He's the CEO of TapTapSee. So Brad, welcome to the show.
Thanks. Yeah, great to be here.
Thanks for joining us today. So I was hoping we could kick things off with just discussing a little bit about the genesis of the app TapTapSee. Where did the idea to build the app come from?
Yeah, in late 2012, we were taking a look at various technologies to do visual search. And the idea at the time was to be kind of like Google for the physical world, where we could create an app and allow people to search just by taking a picture of what they wanted to look for. And as we were building out our image recognition platform, we started seeing that there might be a demand and an interest, and we might be able to help the blind and visually impaired community. And so as we started kind of playing around with the idea, we came out with an early prototype version of TapTapSee in late 2012. And then in early 2013, we started getting a lot of feedback from the Braille Institute, and various users there, and then the American Foundation for the Blind, and it really just kind of grew from there. I mean, we were excited to kind of offer this technology to the community, and we went through a bunch of different iterations to try to make the app as easy as possible to use, and so really it was birthed out of this idea of visual search at first, and then just kind of morphed from there.
And for a non-tech person, like how exactly does that work? Because it does look like magic. Like we take a picture and it's very descriptive, like what the feedback that the app gives us.
Yeah, definitely. Early on in 2012, we did a survey of a lot of different types of image recognition technology that was available. And one of the things we realized early on was that there weren't any good technologies that were able to understand the world around us in a very general sense. So I mean, there's a lot of different types of image recognition technologies, but there's not a whole lot of visual understanding or image cognition, where it's a little different. In
11:07 a.m.
to recognize bits and pieces of an image. But the idea of understanding it's kind of synonymous with how Siri evolved, how voice recognition evolved over the years. We were used to, using different types of voice recognition products, whether that, calling somebody up on one of those AVRs on the telephone, and it would, ask you a question, say help. And it was always very difficult for voice recognition to understand what we were saying until this idea of voice understanding and virtual assistants like Siri came about, where for the first time, this idea of understanding started to take shape for voice. It was a long process for that to actually finally happen, though. I mean, it took, several decades for that to happen. And we've been seeing this kind of evolution in image recognition as well. For a very long time, computer vision would only recognize bits and pieces of what we were showing it in terms of imagery. But it wasn't until, we like to kind of take credit for this, as we started looking at a lot of different ways of bridging that gap between image recognition and image understanding. And one of the things that we recognized early on was that while a lot of different image recognition technologies could recognize bits and pieces of what the computer was looking at, essentially, it had a very hard time gaining that deeper understanding. And so we built a system which later was coined hybrid intelligence, which essentially allowed us to, if image recognition didn't get a good enough understanding of what that particular object or scenery had inside of it, then we would send it off to humans in real time, who would then be able to annotate those images and train the computer vision to help it continuously learn. And so early on, we had a reasonably large percentage of images that were going to humans for correction, But then over time, the computer vision began to catch on, learn essentially in real time. And then finally, it got to the point where computer vision was good enough to be handling, 99.9% of these images, which, then we started moving more towards the computer vision exclusively. And so what's interesting now is even in the computer vision and the AI side, the AI has evolved from, being able to identify something as, say, a brown sofa, to now it identifies it as something like, brown leather, 3-seat sectional something sofa. And so it's really kind of evolved in terms of the amount of descriptive quality that it can generate about a particular scene or object inside of an image.
Yeah, that has always been my one of my questions, right? Because there is some element of very low tech, like in the development of this technology, right? Because and time consuming as well, like particularly in the beginning.
Screen dimmed.
Until you train like the software, isn't it?
Yeah, it is. I mean, it's, one of the most important things with AI is the training data. And I think that there's a lot of focus, or at least there has been a lot of focus put on the AI architecture, the neural network models that the data scientists develop, which I think is obviously extremely important. But there's this unusual effectiveness of having fantastic data. And so, we kind of realized early on that the data was going to be extraordinarily important in order to be able to train these neural network models. And, we've developed highly custom neural network models that we think are state of the art in the way that they're able to really kind of understand what they're looking at. And I think that has a big part of it, but obviously, collecting the data has been a huge piece of that too. To date, we've collected about 750 million records of ground truth. That's about 4,000 times the size of the COCO data set, the MS COCO data set, which is also widely used for training computer vision with these types of tasks. And then the other piece that I think really kind of makes a gigantic difference is in developing this model. Instead of creating like a catalog of items that the neural network could recognize, that the AI could recognize, we instead designed it a little bit more like humans do, how humans identify things, where we have, instead of a finite catalog of items that we can understand as humans, we have a finite number of words that we use, a finite vocabulary, but then we mix and match those words in an infinite amount of ways in order to describe what we're looking at. And that way, if we don't know exactly what a particular item is, we can still come up with enough language to describe it and communicate it to another human. And that way that human can kind of form a picture of what that is in their imagination. And then we've essentially communicated that idea. And so, the network that we've developed is designed with that in mind. It's designed to really kind of develop this deep understanding of what it's looking at and then describe it back to the user.
So I think that's okay. That's very interesting. And so Bruno, this is going to cue you up here, right? Because everybody's listening to this and hearing Bruno's voiceover in the background. So Bruno is going to do a little demonstration for us about how the app actually works. We'll see if he's can fumble through it, because he's not a regular voiceover user. I would use it more often than he does, but he's going to see if we can pull off a live demo here. So Bruno, I'll let you take that away.
Yeah, man, it's very humbling to start using this voiceover here, which I'm doing for the first time. Like it kind of like brings you back to the here it comes to the podcast we had with Randy Pierce recently, right? Which he said that like sometimes a disability like makes you develop new abilities, and then me managing voiceover is definitely an ability that I lack. But here we go. I think I managed like to do it. All right, here we go.
Toolbar, repeat, button.
So I'm gonna
say the last picture again.
I'm gonna
repeating. Picture 3 is orange car toy on brown wooden table.
So there it goes. Could you guys listen it? Hear it?
Yeah, okay, hear that just fine. My only question for you is, why do you have an orange car and a brown wooden table?
Man, I have kids. There are toy cars everywhere. That was a pretty easy pick.
Yeah. No, fair enough.
Yeah, and it's super descriptive. Right? So I'm gonna do another test here. Like I'm gonna get a milk bottle for
Camera
my
button.
daughter.
Button. Camera button. Picture 1 in progress. Picture 1 is pink feeding bottle on brown wooden table.
So there we go. Like I mean, that was the thing that surprised me on the app when I started using it. It doesn't only say like, "Oh, this is a bike" or "This is a chair." Like it really gives as much context as possible, which I found pretty impressive.
Yeah, no, it's definitely pretty amazing how it understands everything. You know, we had this kind of experience. This is kind of one of these fun stories we had as we were developing this technology. But we had showed it an image of these or this cowboy boot, and the system identified it as a women's floral print leather cowboy boot. Well, it understood the gender type and the quantity and the fact that it was a boot pretty easily because there were a lot of boots in the training set. But the leather and the floral print, we couldn't quite understand how it identified that because we didn't have that kind of image in the training set at all. And what we found after we did a bit of digging and looking into it, what we found was that it figured out the leather texture from a lot of different sofas and other types of leather products that people had taken pictures of, and then it figured out the floral print from different types of fabric and textures from dresses and that type of stuff from some of our retail clients through the CloudSight API. And it was able to kind of put these concepts together and accurately identify and describe what it was looking at. And that's when we really kind of realized that, wow, this is pretty cool. This is developed this level of understanding that's far beyond, what we had seen before in the computer vision industry.
Sorry. So, okay. I have a question that comes up to me now is you have obviously put enormous resources, or you or the company's put enormous resources into building this app and building, the image repository. I know we touched a little bit on how that was done and over time. How is this app offered for free to people like me, and like how is that sustainable for the company, or is there certain a revenue stream or future revenue streams for the company to keep everything rolling? Because it would just be terrible for this wonderful technology to disappear from my phone and other people's phones. So I'm just curious in terms of sustainability of the company.
Yeah, definitely. That's a great question. We had played around with a couple of different models, subscription models for TapTapSee very early on, and we actually have some pretty interesting things coming down the pipe for later this year. But primarily, the most of the development and funding and the business model really surrounds CloudSight as the parent company. One of the things we realized with our apps, TapTapSee and CamFind, was that we reached about, I think it were right around 3 million downloads. When we got to that point, we started getting a lot of these kind of Fortune 500 companies contacting us and saying, hey, we want to use your image recognition. And so we started getting the idea to create an API where various companies could subscribe to the API and then send images to the API and get back responses for those images. And so in that way, the platform itself is monetized, but the apps themselves, CamFind is monetized through advertisements, and TapTapSee kind of piggybacks along that monetization model just by we like to offer it to the community as a free service.
So how is where does the images come from? Did you buy a database, or is it all like user provided?
Yeah, it's user provided. So as users, previously when we were still building up this training set, as users would take pictures both with CamFind and also TapTapSee, and then in partnership with some of our clients as well, the clients that are using the CloudSight API, the system collects images and then we use that for training data. So the images have been submitted, through users using the apps, through other partners of ours that send us images. So it's been kind of a collection of all the images that CloudSight's processed.
And is there any image that it's particularly hard for the system to recognize? Because I mean, it's amazing, you know. Like I mean, it gets pretty everything right. The only mistakes, you know, if you put it like that, was between, let's say, men and women, boy and girl. You know, like I mean, sometimes the app didn't quite get it right. Is it a particular challenge, like for you, or is it any other image that is difficult for the system to recognize?
Yeah, there tend to be challenges with images that require a lot more discernible detail in the image to recognize. So, when we send the image to the server, we shrink it down quite a bit in terms of the image dimensions. So that reduces the amount of detail that's in the image. And so, sometimes if you're particularly far away from a subject, it can't catch the little nuances that might help it identify, man or woman, or a particular type of outfit versus another type of outfit, and that type of thing. But we have been slowly increasing that. I know, I think it was about a year or two ago, we released an update that bumped the resolution almost double what it previously was. And then we have some other kind of interesting things that we're working on with moving the neural network models to run directly on the phone instead of sending it off to the server, which allows us to do a bunch of other exciting things directly on the device instead of having to send those images off to the server to get recognized.
So just, you gave us a little bit of an overview of the development of the app over time. I'm just wondering if you have any stories that might be interesting to share about whether they be challenges that you particularly faced during that time. Was there points in time where you thought, hey, this is never going to materialize, or just any highlights along that? I'm just curious if any stories of the development process that you'd like to share.
Yeah, for sure. It was interesting. When we first started working on this project, we really didn't have a good perspective on how users would interact with the app through voiceover and all these kind of assistive technologies. And it wasn't until we started working together with the Braille Institute when we really started getting a good handle on how users would actually interact with it. And that was really fascinating for us as far as a product design perspective. But then as the user base grew, we started getting a lot of really fantastic input from the users themselves, which has been absolutely amazing. I mean, we've heard of some really, really cool stories from people that have, gone to the grocery store for the first time unassisted, or have been able to share photos with their friends and family, and use the system to recognize those photos. There's other users around the world that have been able to use it to learn English, so they'll set the language output to something different and they'll learn English. There's just a lot of different things that we've heard and understood over the years from our users that have really been encouraging us as far as developing the technology. Because to your point, it has been challenging at times to develop a technology like this. We've had points throughout our growth where we've thought, like, is this even possible? Can we do this? And then we've had, those kind of breakthrough moments where it's like, oh my gosh, I can't believe this works. So it's been an exciting ride. I mean, there's been a lot of really fun moments along the company's history where we've been able to achieve new state-of-the-art achievements, and that's always been super exciting. And of course, the best part of all of it is really hearing from the users and how much the app has really helped improve their lives as far as the types of things they're able to do unassisted.
Yeah, that's great. Can you share with us, like, I mean, any future developments? Like, of course, like, I understand that some things might be confidential, but like just an overall direction of the company, or where do you want to take this technology to help people even further?
Yeah, absolutely. Well, yeah, and to your point, there are some things that we can't share yet on the product roadmap. But one thing we've been working with quite a bit, actually, and quite closely with Apple on and off over the past couple of years, is getting the neural networks to run directly on device to the point where it can be sort of like a real-time real-time experience with the app. So you kind of turn on this live recognition mode, and then you kind of walk around the house and identify things, as it scans the room. And this is something that we've been pretty excited about, because it moves the neural network it moves the AI from the server to the phone. So there's an elimination of a whole bunch of requirements in that process. You don't have to have good internet service. Yeah, exactly. I mean, it certainly helps with a variety of things by moving the processing to the phone. And so we're pretty excited about that. I mean, it's been a long time in coming, and we have it working in a prototype. Distributing these neural networks is another challenge, though, because they are a bit larger. The one in particular that runs on the server is about 0.5 gigabyte. So moving that to the phone has been, challenging. And then Apple has their own way of distributing these neural networks. And so that's a process that we've been working with to resolve some issues in the Apple platform. But yeah, I mean, that's something we're really excited about is getting this running directly on the phone, with the users being able to do this sort of live recognition.
So that would be like a video, right? Because right now it's actually a photo. So if we move the neural network to the phone, it would be basically a video recognition, almost like the person is actually seeing it.
Yeah, it kind of feels like that. I mean, it's actually it's a little bit different than video in that it's when we think of video, we think of action recognition. So there's a touch of that, but it's really kind of it's sort of like a live scanning. So it's kind of like right now, if you were to take a bunch of pictures, maybe one per second, that's how it kind of works. And then when it stabilizes on a particular result, then it speaks back to the user, what it sees. And so you kind of have a little bit of a different experience. Instead of having to tap the button when you find something, or like right now you hear the little focus lock beep, and then it that the image is in focus and you can take a picture. This new version, you kind of scan around the room, and it speaks back to you when it seems like it's got a lock on what it's looking at.
And sorry, just a follow-up question there. How easy or hard would it be to offer it in other languages?
Well, it's interesting. We do actually offer it in other languages right now. And in fact, if you have your phone set to a different language, then it should output the response in that other language. And then our other app, CamFind, which is also used by the blind and visually impaired community as well. You can change the output on that app explicitly in the app to other languages. And so it's interesting, actually. TapTapSee tends to focus on describing the entire scene, whereas CamFind focuses on a primary subject inside of whatever you take a picture of. So it's a slightly different type of image recognition technique that both of the apps are using. But yeah, both of them, if you change the phone language to something else, it tends to output in that other language.
This is a lot to digest in terms of what, it seems so, the user experience is so simple and straightforward, but behind the scenes is obviously a lot more complex than that. And I think we've scratched the surface of that, which is certainly interesting for the audience. Brad, I wanted to just take the opportunity to thank you for sharing this information. Again, not only is the audience getting an opportunity to see what's in Bruno's house and on the, demoing the app, but just to understand that, that whole genesis, I think you said started back in 2012, some of this, and an idea of what's coming, I think is certainly interesting. So I appreciate you taking the time to speak with us today about the company. Thanks again. Yeah, appreciate it. It's great to be on the show.
All right. Thank you, Brad. Thank you for coming here. Thank you for what you do as well. It's great.
Thank you. Yeah, I appreciate it.
And that concludes today's episode of the Broad Eye Podcast. If you enjoyed this episode, please be sure to subscribe on your favorite podcast platform. Of course, ratings and reviews are always welcome. And you can certainly share this episode with any of your colleagues or friends who might enjoy it. Thanks for listening.